On your calculator, I want you to graph the three functions, x squared, 2x squared, and look how I put the 2x in parentheses before I square it, and then in parentheses 1/2 x, the whole thing squared. And see what happens here. Well, here, things change. It kind of looks like maybe it's doing the same thing, but we talked about this horizontal. Horizontal and vertical are difficult to tell the difference between. But here, it's the same thing, but now I have my parent function f of x, and now I have f of ax. So I'm changing the x. I'm not changing the answer. I'm changing the input. So when I had it bigger, if I put 2x inside, it looked like it became smaller. It was compressed. So here, a is greater than 1, and here when I had something smaller, it's when a is between 0 and 1. So let's look at this one and see. So if I had y equals 2x squared, if we distribute that squared, I have y equals 4x squared, but remember, now it's like 1/4 of y, right? So I've made 1/4 of y. Or you think about 4x squared in a horizontal direction. How is it going in this direction? Well, if it's 2x squared or 4x squared, it looks like this. So I'm compressing it this way, right? And if it was here 1/4 x squared, it looks like this. So I'm stretching it in that direction. So really, depending on what it looks like in the end, if you have something like this, you have to talk about it as horizontal. But otherwise, you could talk about them just as a compression or stretch, vertical or horizontal. So here, what happens here? It is greater than 1, so it's a horizontal compression, and it's a factor of 3 because it's what's inside. This is a horizontal stretch, and it's a factor of 1/4. And this one, that is outside, is another one. It's a vertical, and it's a stretch. And it's a factor of 3.